Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says minimum time to fulfill all orders. The problem statement goes like, Geek is organizing a party at his house. For the party, he needs exactly n donuts for the guests. Geek decided to order the donuts from the nearby restaurant, which has M chefs, and each chef has rank R. Cool. So we have provided that not all chefs are equal. We are known that. So rank based chef. Cool. A chef with a rank R can make one donut for the first R minute, one more donut for the next 2 R minutes, one more donut for the next 3 R minutes, and so on. Let's see what does it mean. For example, a chef with a rank 2 can make donut in 2 minutes, one more donut in the next 4 minutes. So if a rank is 2, then the first donut is 2 minutes. Then if he prepares second donut, it is in 4 minutes. Then if he tries to prepare next donut, it's in 6 minutes. Nice. So this is for first donut, this is for second donut, this is for third donut. Cool. A chef can move on to making the next donut only after completing the previous one. All the chefs can work simultaneously. Okay. Since it's a time for the party, Geek wants to know minimum time required in completing n donuts. Return an integer denoting the minimum time. Cool. This problem is interesting, although it's very heavily described, and I guess there might be something which we wanted to figure it out, that hey, we can do this and that from the given operations. So likewise, they have mentioned that hey, it goes like 2 4 6 1 2 3 in this fashion. So if the rank is 2, we have this kind of output. What if the rank is 3? We have 3. Okay, 3. Next donut is the second donut. For this, it will take 6 and 9. And this is obviously for rank 1. We can directly get it. First rank. So likewise is the way we see that chefs are working. Cool. Let's understand this thinking within our logic. Okay, we have chef of rank 4 as well. I'll quickly jot it down how 4 rank would work. So 4 4s are 8, 4 3s are 12. So cool. Let's see how does it work and how did we got output as 12 for this inputs. So chef with rank 1 can make 4 donuts at a time. Okay, he can make, and it will cost him how much? 4 5 6 7 8 9 and 10. Okay, 10 minutes. Chef with rank 2 can make 3 donuts, and it will cost him this much amount of time, which is 12 minutes. Nice. And chef 3 can make 2 donuts. Obviously you can see the pattern over here. Higher the ranking of chef, lower the number of cakes or donuts they are preparing. Is there mentioned anything donuts? Okay, donuts. Cool. Anyways, I'll use cake or donuts interchangeably. So cool. Rank 3 makes 2 donuts, which is 9 minutes, and rank 4 makes only 1 donut, which would cost him 4 minutes. Okay, this is one of the way we can go forward. Rank 4 can make 2 donuts, then that would go beyond the time. That 8 plus 4 is somewhat, it's I believe 12. Okay, so rank 4 can make 2 donuts, that's also possible. So rank 4, if I'm making 2 donuts, rank 3 I'm making how many? Some amount of donut. Definitely it's making 2. Let's do it 1 over here. And rank 2 is making 3 donuts, and rank 1 is making 4 donuts as usual, then that also makes sense. That's not an issue with us. But yeah, the ultimate thing which I want to convey is it's not the way how they operate, but it's about the time. So I'll just quickly note it down that it's about time, but not the way they operate. They should operate. So find time. Cool. I have jotted it down so that I won't miss this understanding. Next, I'll jump into the second example. Second, we have all ones with n. Obviously, I can go ahead and assign each one of the one cake, and the output time is 1 because this count is itself 1, 2, 3, 4, 5, 6, 7, 8. This count itself is a 8, and if I'm assigning everyone to make a cake, then ultimately they'll at the first instant itself they will create a cake, and the instant for them is 1 minute because the first instant cost of rank 1. Cool. So this is the case, this is the condition. How can we solve this? Any expected complexity they are asking? Obviously this. So cool. How can we get further? So what do we want it to do here? Let's jump into code. Understandings. How are we going to operate? You see, we are having a certain timeline. So time starts with 0. What if I'm a question I'm throwing out that I want 0 cake. At that time, what do you want? The time should be 0 because 0 cakes are right now at current time itself. At 0th instance, you're having 0 cakes. So from 0, I wanted to find out the time, the x time. But do I have any ultimate time budget, ultimate timeline? A max time, I'll say. In our practical world, we'll tell it as infinity, but we are bound to have max time over here because we know the max time. I'll tell you how we can calculate the max time. But what we can get out of this intuition or this visualization is that the time is increasing and it's bounded. So that means we can very well go ahead and apply binary search upon this, which would ease our time. And why we are applying binary search? Because we don't want to go ahead and calculate for t is equal to 0, then I will calculate for t is equal to 1, then I will calculate for t is equal to 2. That is going to time consume me a lot, and that's not very efficient as well. So I'm applying binary search to understand at what instance of time I can get the value. So cool. How I can go ahead and do this, and what would happen if I calculated the time itself? Okay, I'll tell you. First of all, let's understand what are the minimum and maximum limits I can get my hands into. But prior to that, some refactoring. I'll call it as A for simplicity purpose, and N doesn't make sense. I'll call it as C because it's a target cakes. Let's say target itself. Target makes sense. So int n is a dot length. I'll say bluntly int l, or I'll say min, or what should I say? Min time works well. Min time is 0, and int max time is equal to get time for creating what? Creating the cakes for our target. But who will create this cake? You see, if you wanted to create a maximum time, you would give every order to the chef with the highest rank. That would produce the maximum times. You see the pattern over here. Minimum time is consumed by minimum chef, minimum number of minimum chef. Sorry, the rank of minimum chef. So if I have only one cake, I'll give it to the chef of minimum. rank. So what I'll do here is I'll get the highest rank shift and -1, and then I'll take the target from it. And I have minimum time, I have maximum time, so why not just go ahead and while min time is less than max time, and while I'm doing this I'll have a mid. Mid is nothing but min time plus max time minus min time divided by 2. Cool. Nice. Now what I'll do, I wanted to check that, hey, how many cakes I can produce at this time. So num cake is equal to create cake for this amount of time. I'm using methods and functions everywhere so that I wanted to make this code clean, and I want you guys to understand what my thinking process is. And if you can improve my thinking process, please do. I'm looking forward for it. So I'm asking you that how many cakes can I create for this time, this mid time. I'll take this mid time. So create cake with A for mid time. I'll quickly understand the get mid time. So I'll just get time, and it takes rank, and it takes target, or I'll say cakes. Anything works fine, target as well. So I'll just return, because you see these are just nothing but if rank specific. So if I took out common from this as 2, I'll just multiply it by, it would be 1 plus 2 plus 3, and if I took common as 2, it would be again 1 plus 2 plus 3, and same doing for this, 3 to common out of 1 plus 2 plus 3, and you can see it very well that it is nothing but the sum of n natural numbers, and you know the sum of n natural numbers is t into t plus 1 divided by 2. So t natural numbers is this, and I'll just multiply it by r, because I took r as common out of them, like this. So far so good. I got a time, I have implemented this. Let's see how can we do this with create cakes. So create cake, okay, I'll take it out. Create cake is a method which would return as int, which would take as array a and int time. Cool. And what does it is create cakes. What can be a better name? What does it do is, just understand, is returns count of cakes one can create till time t. So it's that only stuff, nothing rocket science over here. So I'm creating a count variable which is initially 0 for int I is equal to 0, I is less than a dot length I plus plus. And now for each cake I'm increasing the count, and I would say that the contribution of this can be num cake of a of I to t, and ultimately I will return the count. That's it. What num cake would do, num cake would pinpoint the individual contribution. So it will return the integer, it will have the current rank with current time, and it will say that for this rank how many cakes till time t. So that's it. So till time t how many cakes can I create? So it will also return a count cnt, and with that cnt, one thing comes here is it and max time. So max time, how far can I go? Because max I wanted to keep a track of max time where we are. So I into R. Why I'm doing this? Because I wanted to understand if rank is 100 and T is 1, I can't even create one cake. So I can't even iterate upon even the one cake. So I'll also have a variable as iterator, which is 1 initially. So max time is nothing but it will iterate ITR. Anyways, that's a max time. And what I'll do with max time is I wanted to understand that, hey, if max time is lesser than your target time or equal to target time, because I can complete in that time as well, is less than or equal to your target time, then I can count this because I can create this one. And I will attempt for next iteration that he can create the next amount. So if I can create one cake, it would be 1 and it would be 2. So it's a candidate, you can say, candidate for 2 ITR, and count is the count of how many done. So it's a done count, it's candidate count. And I will update a max time, and you see how can I get time from a rank with a cake, with the number of cakes. So we have already a function get time. So I'll get a time for current rank and the candidate. So we already have this function right here, get time. So cool. We have this. We return a count, and number of cakes gives individual chefs count, and individual chefs count we are counting on the count variable over here, and we sum it up and gave it as here. Now we got to know that, hey, I can create these number of cakes. So what is stopping it to us? So I'll check that, hey, if these number of cakes, how can I deal with? So I'll say num cakes if it is greater than or equal to target. So yeah, it's success. So if it is successful, I'll just go ahead and have a variable. Maybe I'm on the higher side or equal to. So there are both of the cases. So higher, it's success, maybe equals or higher. So for higher, I will deal it first. For if I'm on higher side, I'll do mid -1. But if I'm on success, I wanted to store the result mid time. Else, what I'll do is L is equal to mid +1, and I'll return mid time. Result. And this is nothing but I wanted to add a new variable, I guess. Int result is equal to -1. Initially it's -1, and yeah. So far so good. Let's compile this for any compiler errors. Okay, there are many. So there's not mid, it's mid time. There's not L and R, sorry for that. Max time and min time. Anything else do I have? Cool. Let's try to submit this one. Okay, we got an error. So we wanted to do min time is less than or equal to max time. Now this will work. Let's hope so. Yes. That was a very silly mistake, by the way. And yeah, our solution passed all the test cases, and this was a very good problem from binary search. If you wanted to know more about binary search, click the video on your right, and I'll see you in the next one.